From the many craters scarring the moon's marred surface to the strange, slanting rings surrounding Uranus, our solar system bears the scars of impacts that echo its violent past. Over the last 4.5 billion years, the planets have spiraled, shuffled, and migrated, sometimes intersecting one another's trajectories and even colliding. In every region of our solar neighborhood, evidence of cataclysmic impacts is etched into the very recipes of our neighboring worlds. In this exploration, we journey back to a bygone age of intense violence around the young sun. Last time, we discussed the history of Earth, but with one key detail omitted: the formation of the moon. It seems fitting to begin with that story as we revisit the many collisions of the early solar system. However, to understand the moon's creation, we first need to look even further back, to a time before the terrestrial worlds we know today: Mercury, Venus, Earth, and Mars. These four rocky planets are the products of over 50 million years of catastrophic collisions between hundreds of smaller protoplanetary objects, all forged within the furnace that birthed the solar system. This close to the blazing heat of the infant sun, only molecules of rock could survive as building material, while volatile substances like water vapor and ammonia were pushed outward by solar winds. Consequently, when the accretion disk that formed the solar system dissipated, the inner solar system was populated by over 50 Moon-to-Mars-sized molten planetary embryos. As accretion gave way to chaos, these planetary embryos began careening around the inner solar system in eccentric, elliptical orbits. Apocalyptic collisions between planetesimals ensued as embryonic cores plowed into one another, melting their rocky surfaces and coalescing into larger, more massive bodies. After tens of millions of years of this cosmic dance, the rocky material concentrated into a handful of large terrestrial planets, including the smoldering mound of radioactive rock destined to become Earth. Within just 20 million years of its formation, young Earth accrued around 90% of its present mass. But soon, it faced a dramatic encounter with another protoplanetary object, Theia. This Mars-sized body, named after the mother of Selene in Greek mythology, veered into Earth's path. Gravitational influences from other planetesimals disrupted Theia's orbit, causing it to intersect Earth's trajectory. Approximately 4.5 billion years ago, Theia collided with Earth at a 45-degree angle in the most devastating blow the young planet ever endured. The impact obliterated Theia, shredding its outer layers and blasting a massive hole in Earth's crust. Enormous chunks of rock from both worlds were dislodged and vaporized, casting a superheated cloud of debris into orbit around the battered Earth. Within hours, this diffuse ring of debris coalesced into a single, dominant body, the Moon. Theia's destruction gave birth to Earth's only natural satellite, Luna, by far the most complex in the terrestrial neighborhood. Ever since, the Moon has watched over Earth, exerting gravitational tugs that drive oceanic tides and stabilize the planet's axial tilt. This version of events, known as the giant impact hypothesis, has been the mainstream scientific explanation for lunar origins since the 1970s. While alternative theories exist, none explain the Earth-Moon system's fundamental properties, compositional similarities, the Moon's molten past, and the angular momentum, like the giant impact hypothesis does. The strongest evidence for this theory lies in Earth's axial tilt and rotation speed. Earth spins on an axis tilted 23.4 degrees from its orbital plane, implying a massive impact must have knocked the planet over and accelerated its rotation. Without this collision, days on Earth would be longer, and there would be no seasons, two critical factors that have shaped life's evolution. The Theia impact also played a pivotal role in Earth's mass. Without the collision, Earth might have missed accruing the final 10% of its mass. Even slight differences in mass, density, or gravity over billions of years could have profoundly altered the course of life, possibly preventing it from evolving beyond the oceans. The Moon, born of catastrophe, has thus been instrumental in Earth's habitability. While Earth benefited from its giant impact, Mercury endured a different fate. Once a promising protoplanet, Mercury was ravaged by colossal impacts, stripping it of its mantle and sending it into a tormentedly close orbit around the Sun. Mercury's oversized iron core, making up 85% of its diameter, suggests it once had potential for greater size and distance from the Sun. But a massive collision dislodged its mantle and left it as the dense, volatile world we see today. Simulations of Mercury's history suggest either a single perfect impact or a series of smaller collisions altered its fate. However, reproducing Mercury's current state remains a challenge for scientists, making its formation one of the solar system's enduring mysteries. As the chaos of the early solar system unfolded, another significant event reshaped the terrestrial neighborhood, the Late Heavy Bombardment. Around 4.1 billion years ago, Neptune's migration toward the outer solar system dislodged asteroids, sending them careening through the inner solar system. This relentless bombardment, lasting 300 million years, carved out features like Mercury's colossal Caloris impact basin, a 1,500-kilometer wide scar created by a massive projectile. Beyond the inner planets, Uranus also bears the marks of a giant collision. Unlike other planets, Uranus rotates on its side, likely due to a massive impact with an icy super-Earth at least twice Earth's mass. This collision rolled Uranus over, altering its magnetic field and resulting in its unique system of chaotic moons and rings. Farther still lies Pluto, the disowned dwarf planet of our solar system. Once considered the ninth planet, Pluto was reclassified after the discovery of other similar-sized icy worlds in the Kuiper Belt. Pluto's largest moon, Charon, is thought to have formed from a giant impact or was captured by Pluto's gravity. The system's additional small moons, Nix, Hydra, Styx, and Kerberos, pose challenges for simulations, adding to Pluto's enigmatic nature. One of Pluto's most fascinating features, the Tombaugh region, is a heart-shaped nitrogen ice plain likely formed atop an ancient impact basin. Beneath this icy surface, evidence suggests the presence of a subsurface ocean, defying expectations for such a cold, distant world. The solar system's violent past has shaped its planets and moons, leaving scars that reveal stories of destruction, creation, and transformation. From the birth of the Moon to the torment of Mercury, the mystery of Uranus, and the icy enigma of Pluto, these cosmic collisions remind us of the delicate interplay of forces that have shaped our celestial neighborhood.